So we'll take a look and see what you guys got. Let's see.
Oh my goodness, yes. I was telling you yesterday. It's because I could get it.
Okay, so you guys said that your, these are what, ages? Are these ages?
Ages. Yeah.
So don't forget to label it ages. These are frequencies, or relative frequencies. I'm going to do frequencies because I'm lazy. They're easy to write down numbers. All right, so you guys said the first imaginary class was 12? 12, 17, 22, 27, 32, 37, 42, 47, and 52. So then your frequencies went as high as what? 7. And the first one was 4?
0.
Well, okay, so I'm going to do 17. 17 was 4?
Yeah.
And the next one was 7? And then 5? And then 3? 0, 0, 1? And then we're going to put in the imaginary ones. So the 0 in front and the 0 in the back. And then just connect them all with lines. No big deal. Piece of cake. Good? Yes? All right. Perfect. So incidentally, on your homework, it will have you go from blank to blank, from like 12 to 17. When you go from 12 to 17, make sure, you guys pay attention. Make sure that you grab the stick, the dot that says 12 to 17 when you go from 12 to 17. If you just go, it goes 12 to 17, 17 to 22. If you do this one and then you do the 17 to 22, you use this dot for that one. If you click on that dot and use that line, it's going to mark you wrong. It wants you to take this one first, then click on this one and do that one next, and then click on the next one. You have to kind of go in order of the stick. If you grab the wrong stick and put the wrong stick in the wrong spot, it will mark it wrong, even though it looks perfect. Do you understand what I'm saying? Mm-hmm. Okay, so be aware of that. Okay. Ogives. These, you'll also have 2 or maybe 3 homework problems on this one. They use the upper class boundaries and either cumulative or relative frequency. So it's one of the cumulatives, either regular cumulative frequency or cumulative relative frequency, either one. And again, because they're cumulative, they always go up, they always increase, right? You can't have 2 people who read 5 or less books and then all of a sudden only have 1 person who read 10 or less books. So it's always going to go up, and it should end with 100% or all the people. These are your upper class boundaries, and I'll explain why we use those. Very, very often, you want to know how many in a sample are less than some value. So in other words, look at this one. Can you guys tell me how many runners ran 8 or less miles? So take a look and see how many ran 8 or less miles.
1.
For sure, 1?
No.
You're not sure. There's 1 person, and you don't know whether they ran somewhere between 6 and 10 miles, but you don't know whether they ran more than 8 or less than 8. Do you guys see what I'm saying? These are the boundaries. So the boundaries would go as 6. Oh, how do I know that? Remember, my boundaries are always 1 more decimal place than my real data is in. So remember that part? So if my boundaries have 1 decimal place, my data has how many decimal places? None, 0. So my data would be in whole numbers. So I know my data is in whole numbers. That's how I knew that. So if I kind of look at that this would go with what kind of tucks in inside of there, 6 to 10. And then the next whole number up from 10 and a half would be 11. The number down from 15 and a half would be 15. So that one must be 11 to 15. 16 to 20. So my question is, how 8 or less? There's one guy that ran between 6 and 10, but I don't know whether he might have run 6. I don't know, or he might have run 10. I'm not sure. Or any number in between those two. So maybe he ran 8 miles, maybe he didn't, I don't know. What can I say for sure? One runner ran, well, between 6 and 10, or at least, not at least, blank or less. Can I say blank or less? One runner ran blank or less. What would be the blank? 10 or less. Does everyone understand that? 10 or less? And even more so, I could say that one runner definitely ran less than 10 and a half miles. So look at everyone who ran less than 10 and a half. There is one who ran less than 10 and a half. So you guys see what I'm saying? The boundary means you can say less than. Or as always, you guys say less than or equal to. All right, so answer me these questions, which you kind of answered one of them. 10.5 or less, well, less than 10.5 miles. You said 1. How about 15 and a half or less? 3. All these guys. What do we call that? Cumulative frequency. Right? Cumulative frequency. So this would be 1 person there, 3. What's the next one? How many were this much or less? 6. What about this much or less? 11. Right? Because 5 plus the 6 from before. And then how about 30.5 or less? Yep. 4 here plus 11 from before. 18. And then 2 plus 18, 20. Okay? So that's why these ogives, you have to use the upper boundaries. Because 15, 30.5 miles, less than 30.5 miles. You can't say 15 people ran less than 25.5 because these 4 didn't run, they ran more than that. So you have to use the upper boundaries. Upper boundaries and cumulative frequencies. Those are the 2 things you have to use upper boundaries. You'll have, like I said, you'll have 2 homework questions on that, 2 or maybe 3. There's also scatter plots, which are pretty straightforward. We talked about those last class. I'm not going to explain them again. Maybe I'll mention them. Okay, so scatter plots, each point represents an x and y value. So like this guy here is one person. He has 2 things we know about him. His waist circumference, which is like 82, and his arm circumference, which is maybe like 26, 27, something like that. Bar graphs, they use vertical bars or horizontal bars whose heights or lengths represent the frequency. A histogram is one example of a bar graph that always goes up, right? And has numbers along the bottom. Here's another histogram that you can have a multi-histogram. So you've got 2 or 3 things being shown for each spot. And then protocharts are another type of bar graph, which this is a bar graph that again goes up, but I explained this already last class, didn't I?
No.
I didn't? Oh. Maybe briefly. Really? Okay. So protocharts, so a histogram will always have numerical things along the bottom. Numerical things have to go in order. Like you can't go 0 to 4, and then 5 to 9, and then 20 to 24, and then go back to 10 to 14. You know what I mean? They have to go in order. Does everyone understand what I'm saying? Yeah.
On the notes, so would the histogram be, a histogram is a graph that displays the data by using vertical bars?
No, that's a bar graph. Yeah. Histogram is one version of a bar graph. A histogram is a special case of a bar graph where they only go vertically. They can't go horizontally.
So there's another thing on here that says light uses a vertical and horizontal bars whose heights or lengths represent the frequencies of the data.
That's bar graph.
That's what I have. So that's a bar graph.
Yeah.
Those both are gonna be bar graphs?
Oh, what's the first one? I'm sorry, maybe I didn't hear you right.
I said the blank is a graph that displays the data by using vertical bars of various heights.
Oh, that is histogram. Sorry.
No.
Yeah, I didn't hear. I thought you said. I thought I heard the word vertical in there,
Oh,
horizontal in there also. But yeah, my bad. Various height. I think. Yeah. I think somehow the various heights. I heard that wrong. Okay, cool. So bar graphs can go vertically, like that, or horizontally, like that. They can be for data that is categorical, like soccer, softball, basketball, auto, bus, trolley, train, or they can be numerical. Yeah, go ahead.
So if proportions are used instead of frequencies, the graphs are called blank graphs. Would that be a good time series?
Nope.
Or
What happens when we use percentages, relative frequencies?
no, it's relative frequencies.
Yeah.
Okay.
Yeah. Good questions. Glad you guys are asking these. So Pareto chart is another type of chart where numerical, like I said, numerical has to go to order. 0, 1, 2, 3, 4, 5. You know what I'm saying? You can't go backwards. You can't have 5 before 3. But if you're talking about categories, it doesn't matter. You can have trolley before auto, before walk, before bus. It doesn't matter what order they're in. Does everyone understand that? So Pareto chart is a special chart where you have categorical data arranged from most frequent to least frequent. So you start at the highest spot and you go down. Adam.
When you say, like, is it Pareto?
Pareto, something like that, yeah, Pareto.
You say the Pareto's for, like, qualitative data?
It is for qualitative data, absolutely. So yeah, so this is only for qualitative data, categorical data. So remember, qualitative labels, right? Not quantitative. Good. Thank you for thinking about that. Love that. Everyone's growing their minds. And then we have, so wait, Pareto chart, is that what, how's it arranged?
Highest frequency to lowest.
Highest frequency to lowest. You will need to know that for your project stuff. It's going to come up. Pie charts, we talked about that last time. We talked about how the whole circle is 360 degrees, yes? And if you, did I really not talk to you guys about that?
No.
I think he just skimmed over at the end.
Yeah,
Okay. Okay, so a pie chart is where the whole circle is 360 degrees, and the area that each section, each category represents is found by, I guess the percentage that each category has is the percentage of the pie that it gets. And how to figure out how many degrees it has? So like this from here to here is 180 degrees. Because there's 360 degrees in a circle. Everyone heard of someone doing a 360? That means they do a full rotation. Right? A 180 would be they're going this way, all of a sudden they're going that way. They do a half rotation. So here, the way we figure out how many degrees are in each section of the pie is we take the percentage that it represents as a decimal, so 50% would be 0.50, multiply that by 360 degrees, that tells you how many degrees are in that section. So for this section, you take 0.18, multiply it by 360 degrees, and that would give you the number of degrees that would be under single. Make sense? Okay. So what I want you guys to do next is, for lab problem 6, let's go ahead and agree upon what percentages we think each of these things are. That would just make things easier for people, I think. So porosity, this first one here, we need to arbitrarily decide how many, what percent that is.
15.
15? Great, 15%. Next one, Welding, what do you think that one is?
10%.
10%? Sure, why not? I'll go with that one. Next one,
8.
what's that?
8%.
8? You guys want to do 8? It seems a little high. Well, you can do 8. 7? Can we do 7 at least? Next one?
5.
5? Okay. We're going to run at 20, 30, 20, 37. We actually can't, we got to drop these down a little bit because I'm going to
So
make this one
4.
4 because the problem is otherwise we're going to have no room for this one's going to be
2%.
not reasonable. What's the next one?
2.
2? 1?
Or
We do
1.
1?
1.
Okay, we'll do 1. So we add those up. 25, 37, 60, 63. That's a little low here, but that's fine. 63%. Okay. Now, this is what you need to do. You need to figure out, the first one, shrink. Right? Figure out how many, you're going to multiply some numbers or something like that to end up with some number of degrees that should be in that one should be. And do the same thing for porosity and all the rest. You're going to figure out how many degrees are in each of these arcs. All right, so this one has 180 degrees in it. Married is 180. Figure out what single would be, a divorced would be, right? Your job is to figure out what shrink, porosity, weld, shell, HA, and tungsten would be.
So 15 divided by 60, right?
Velocity. Weld. Shell. So figure out figure out the degrees for each of these. To the nearest 10. And you might need that information next. Okay? So, let's say once you figure that out, take a break.